All right, today's lesson is about proving triangles are congruent. First, we're going to talk about side, side, side. So that's a postulate that if all three sides of one triangle match all three sides of another triangle, then you can say those two triangles are congruent. All right, here is the given information. First off, you'll have to draw these two triangles on your paper. All right, so first we're going to mark that MN is congruent to QR. All right, then we're going to say that NP is congruent to RS. Now I'm putting a different number of hash marks because I don't want to say that NM is congruent to NP. I don't know that. It didn't say that. And the last side is PM is congruent to triangle SQ. PM is congruent to triangle SQ. Now we can see that all three sides of this triangle are congruent to all three sides of that triangle, so these two triangles are congruent. Here is a congruency statement. I'm going to change the order. I'm going to start with N. I'm going to say triangle NPM is congruent to triangle. Since I started with N in the first triangle, that means I need to start with P. I want to identify the corresponding parts of the triangle. So it would be RSQ. Those two are congruent by side, side, side. All right, now we have a proof. Let's do the given information. AB is congruent to DB. Okay. Then it says AC is congruent to DC. Now I have two sides. I am missing the third side. This third side is right here. Okay, since they overlap or they share a side, that is congruent. We call that reflexive. So sometimes we need to add some more information in order to prove that these two triangles are congruent. So BC is congruent to BC because it's reflexive. So that would be another reason used. Okay, so now I can say the triangle ABC is congruent to triangle DBC. But I want us to practice changing the order of the letters because it's important that we are able to name the congruent triangles in the right order. So I'm going to say triangle BCA. So I went BCA. I'm going to go BCD to name the other triangle because I want to make sure I'm in the same order. Okay? They are both congruent by side, side, side. All right, here is another proof. MN is congruent to LP, or I'm sorry, LM. I don't know why I said that. And LP, okay, they're congruent. NP is congruent to NM. NP, NM, okay. Again, we have this shared side, so we can say LN is congruent to LN because it's reflexive. So these two triangles are congruent by side, side, side. Let's change the order of what we have here. I'm going to start with, I'll start with M here this time. So I'll say triangle MNL is congruent to triangle. Since I started with M, I'm going to start with P. I went from M to N. I'm going to go P to N. So PNL. By side, side, side. Okay, so now we have some coordinates. We need to graph the triangle, and we're going to use the distance formula to show that they're congruent. Just to remind you, the distance formula is the big square root of the difference of your x coordinates squared plus the difference of your y coordinates squared. All right, so first I'm going to graph triangle ABC in blue. So A is negative 7, 5. Negative 7, 0. I'm going to label my points. And negative 4, positive 5. Let's see. All right, cool beans. I'm going to graph the second triangle in red. So F is 6, 2. G is 1, 2. And H is 6, 5. All right, and I'm going to connect to make my little triangle here. Now remember, I told you guys with vertical and horizontal lines, it's okay to count the units. You do not have to do the distance formula on a vertical or a horizontal line. But if it's a diagonal, you should use the distance formula right there. All right, so here's a horizontal line, 1, 2, 3, that's 3 units. Vertical, 1, 2, 3, 4, 5. That's 5 units, okay? I need to know what the length of BC is. So that means I'm going to use these two ordered pairs into this formula here. So it says -4 plus 7, because that's minus -7, plus 5 minus 0. Well, -4 plus 7 is 3. 3 squared is 9. 5 minus 0 is 5. 5 squared is 25. When I add those together, that gives me the square root of 34. All right, those are all 3 sides of triangle ABC. Now I'm going to look at the other triangle. I see vertical and horizontal lines. So 1, 2, 3, 4, 5. 1, 2, 3. Okay. Well, now I can see that AC is congruent to HF, and AB is congruent to FG. All right, I'm just missing that third side. I need to find the length of GH. So I'm going to use these two ordered pairs for GH. So 6 minus 1 squared plus 5 minus 2 squared. All right, 6 minus 1 is 5. 5 squared is 25. 5 minus 2 is 3. 3 squared is 9. It looks like they are the same length of square root of 34. So now I can also say that CB is congruent to GH. All right, so all 3 sides are congruent. Guess what? These 2 triangles are congruent by side, side, side. The triangle ABC is congruent to triangle. We have to name it in the same order. So if I started with A and I went to B, so I went over the 5 and then over the root 34, yeah, I got to do the same thing. Over the 5, over the root 34. So I'm going to start with FGH. That's how I'm going to name it. FGH by side, side, side. All right, so if you have to do the distance formula, you need to do the distance formula, okay? We're not going to just look at it. I'm not going to get out a ruler and measure it. We have to use math. All right, so now we're going to talk about side angle side and hypotenuse leg, 2 other postulates we can use to prove triangles are congruent. So here's the given information. All right, PQ is congruent to WX. All right, angle Q is congruent to angle X. And side QS is congruent to side XY. All right, so now the angle that's congruent is between the 2 congruent sides. So it's side, angle, side. That's what it looks like, okay? If we want to change the congruency statement from what's shown here, let's say I start with Q and I go QSP. The triangle QSP is congruent to triangle. Since I started with Q, I have to start with X since they are corresponding angles. So X, Y, W. That's how I would name it, by side, side angle, side. Okay, so now we got some stuff here. We got AE is congruent to DE. Okay, AE, DE, fine. BE and CE are congruent. BE, CE. We also have vertical angles right here. I don't know if you see that or not. So I know that angle 1 is congruent to angle 2 because of the vertical angle theorem. Okay, so now what do I have? I have a side, I have an angle, I have a side. So these 2 triangles are congruent. Let's switch the order here. So let's say I start with I go EBA for my triangle, right? So I went EBA, I'm going to go ECD. Oh, I forgot to put the triangle in front. Oh no, Garcia. All right, so triangle BECD by side, angle, side. All right, this is not an example of SAS, okay? Because for SAS, we're looking for the given angle to be between the two sides, okay? So here, I have an angle, I have a side, and look, remember this is reflexive, I have that, but what does this spell? Angle, side, side. Yikes. That's not good. That is not a congruency statement, okay? So always look for SAS and not as. Okay, let's look at another proof here. It says BC is congruent to DA. Okay, then it says this. What this means is side BC is parallel to AD. So if we have parallel lines, remember we put little triangles on them, that shows that they're parallel. When you have parallel lines, you're looking for alternate interior, corresponding angles, you're looking for some sort of congruency so that you can make your congruency statement. So I see here that angle BCA is congruent to angle. So see how I named it? BCA. I'm going to go DAC right here. Those two. Because guess what? Those are alternate interior angles. Alternate interior. All right. And let's see, I have a reflexive side, right? So I have this guy. AC is congruent to AC because it's reflexive. So do I have enough information to say that these two triangles are congruent? I have a side, I have an angle, I have a side. So yes, I have side, angle, side, but I want to name them. So if I say triangle BC, oh, that's not what I meant to say. All right. BCA, so BCA, I'm going to say DAC. I want to make sure that I'm going over. So I went B over my parallel to my angle down the middle. And I started D over my parallel to my angle down the middle. So DAC by side, angle, side. All right, the other one is hypotenuse leg. This is actually fairly simple. It only applies to right triangles, only in a right triangle. Only in right triangles, right? This is the hypotenuse, everybody. All right, meaning this is the leg and that is the leg, right? So legs are here. This is the hypotenuse. I'm just going to abbreviate it. It makes my life a little easier. All right, we're going to fill out the given information. AB is congruent to AD. AB, AD, great. AC is congruent to AC. Well, duh. Okay, so now you only need two things. This is the only one that you need two things to match up in order for the two triangles to be congruent, only if it's a right triangle. You need one of the legs and you need the hypotenuse. So these triangle BCA is congruent to triangle. Now I said BCA, I'm going to go DCA by hypotenuse leg. All right, what I want you to do is separate these two triangles. You see how they're together up here? Look down here. Now they're separated. All right, I'm going to try to bring them up. I'm not sure why they are so far down there. There we go. All right, so once we separate these triangles, we can look at, because that's kind of crazy to look at. Let's see the given information. So WY and XZ are congruent, okay? Then it says this. Do you remember what that upside down capital T is? That just means they're perpendicular. So that means where these two intersect, they make a right angle. So where these two intersect, they make a right angle. Great. It also said, oh, well, it's talking that this is perpendicular to that. That's lovely. Sorry, I just did both of these at the same time. So check, check, check. We gave the given information. Okay, so I have a hypotenuse. I'm just missing a leg. If you notice here when they were overlapping, they shared the same leg at one point. So that's going to be reflexive. So ZY is congruent to ZY because it's reflexive. So now these two triangles are congruent by the hypotenuse leg theorem. So let's name them YZW. So triangle YZW is congruent to triangle. So if I started with Y and I went to Z, I'm going to go from Z to Y over here in the other one and up to X. By the hypotenuse leg theorem. So they're both congruent. All right, here is your assignment for 4.4 and 4.5. Let me know if you have any questions. Hopefully this video, you could hear me and it all worked great. All right, have a wonderful day.